start. Hello students, it's once again your teacher, Mr. John Kizito from Namugongo Secondary and Vocational School here in Janda. I'm here to continue with you in Chemistry Paper 3, mainly dealing with quantitative analysis, which I told you sometimes we call volumetric analysis, a technique of chemistry that deals with finding out the concentration of a given substance within an unknown sample. Last time we went through how we get the results in the table as we see them in the screen, and how we deal with the different kind of materials or apparatus, how we set them up to get our results. Today we are going to deal with mainly calculations, how we treat the results obtained to come up with a concentration of the unknown, because we had one solution whose concentration was known, that was hydrochloric acid, 0.01 molar, and we had sodium hydroxide whose concentration was not known. Therefore, how do we deal with the results we got in the table to come up with the results? In the table, first, we have the values. As you sit down there, we have volume of hydrochloric acid used. I told you we do 3 trials. Trial 1, trial 2, and 3. And we get the volumes down there. But we cannot use all the volumes because that was the volume of hydrochloric acid that completely reacted with the sodium hydroxide. We need only one, but we cannot know which one. Therefore, we take what we call average of 2 values that seem to be close to each other. And when you look into the table, it seems 24.60 and 24 and 24.50. These 2 values, cubic centimeters, seem to be so close to each other. After the table down, the examiner will ask you to write the values that you are going to use to get the average, because average will be the most correct value that you are going to use in your calculation as volume of hydrochloric acid which was released from the burette. So we are going to use these 2 to get the average volume of hydrochloric acid. And what do we do? At first they will tell you to record them, and when you record them like this, these ones earn you a full mark. A full mark. After recording these values, the second question will ask you to find out the average volume of hydrochloric acid which was used. So what you do is to add them up, 24.60 plus 24.50 divided by 2. Why do we divide by 2? Because we are finding average. And when you add these 2, you come up with the 49. What do you get when you add this? 24.6 plus 24.5. This is a 1, this is a 9, and this is a 4. So it is 49.1 divided by 2. And we shall come up with our average volume of hydrochloric acid used as 24.55 cubic centimeter. Once you have this answer, it earns you another full mark. But this full mark is awarded when you show that you have divided with it to finally to get the final 1 mark. So the next thing we shall be having is now calculating the number of moles of hydrochloric acid that were reacted. And in Chemistry Practical, we do everything from first principles. Here we don't use formulas. However much, there are many in chemistry that we can use to get number of moles, but we use first principles. In other words, we use definitions to find out the concentrations. So what we are going to do here, for question 1, to find the number of moles of this HCl, whatever you're doing now here is for hydrochloric acid. Don't forget this. So it says this is the volume of HCl that reacted completely with sodium hydroxide. For us to get the number of moles, we are going to use molarity. And what is molarity? According to your theory, molarity is simply defined as the number of moles in 1,000 cubic centimeter of solution. Or sometimes we can call it 1 liter. The number of moles you can find in 1 liter is what we call molarity. And our molarity, according to the question of HCl, was given as 0.1 molar. So that means this number of moles are in 1,000 cubic centimeter of this solution of hydrochloric acid. So what we are going to do, we are going to use the definition of molarity to write the first statement by saying, if 1,000 cubic centimeter of solution, okay, contain, according to molarity, because this was the molarity 0.1 molar, contain 0.1 moles of what? Of hydrochloric acid, HCl. This is a full definition of molarity. Therefore, we are going to bring this volume that we got from our titration. What about the 24.55 cubic centimeter of solution? Will contain how many moles? So now what we are going to do is cross multiplication. And when we cross multiply, if you put any unknown here, when you cross multiply, you'll have this value here, the 0.1 molar, 0.1 moles, times the value on the same line with it, which is 24.55 divided by the first value, 1,000, divided by 1,000. Everything we have here is in moles. And these are moles of hydrochloric acid. Okay? These are moles of hydrochloric acid. You compute in the calculator. When you compute, you will find that you get the number of moles as 2.455 exponent 3. Exponent 3, and these are moles. This can be written in decimal places. So this is a number of moles of hydrochloric acid, HCl, that reacted, because the question was to find out the number of hydrochloric acid that were used in titration. Why in titration? Because this is the volume that we got after titrating. And this is how we get the number of moles of hydrochloric acid. The second task we have is now to find out the number of moles of sodium hydroxide using the number of moles of HCl. But we cannot do that before we find out the mole ratio, the ratio into which these two solutions reacted. And we get that from the equation of reaction. So if you cannot see what we have put here clearly, it is displayed somewhere on your screen. You'll be able to follow together from there. We're going to proceed and find out the number of moles of sodium hydroxide that completely reacted with the hydrochloric acid from the burette. But I've said we cannot do that before we write the equation of reaction. So what we are going to do is to repeat the equation of reaction, which I've given you some time back, but we are going to repeat it for remembrance. We have sodium hydroxide It's an aqueous solution reacting with hydrochloric acid, also aqueous, to give sodium chloride, also aqueous, and water. What we do to get the mole ratio is to first balance this equation. After balancing, we shall then know how many moles of one species can react with another species. So we balance atom by atom. Here sodium we have 1, and this side 1. Oxygen we have 1, and this side 1. That one balances. Hydrogen we have 2 of them, and this side there are also 2. Then chlorine we have 1, and this side chloride is also 1. So therefore, our equation balances. It does not need to put any figure to balance it. So, writing the mole ratio of sodium hydroxide to hydrochloric acid is 1 to 1. Because only 1 mole of sodium, as you see here, there's no figure in front here, and there's no figure in front here. So 1 mole of sodium hydroxide requires 1 mole of hydrochloric acid for complete reaction or for complete neutralization. So we can also use mole ratio in first principles by saying if one from mole ratio, from this ratio, if 1 mole of hydrochloric acid, why are we starting with hydrochloric acid? Because it is what we know, and we are finding out sodium hydroxide which we don't know. Here we calculate from known to unknown. So this 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide solution. If that one is true, therefore we can also bring these moles of hydrochloric acid and find out how many moles of sodium hydroxide they can react with by saying, what about the 2.455 exponent 3, negative 3? What about these moles of hydrochloric acid will react with how many moles of sodium hydroxide? Will react with, you do the same thing we did in the previous example. You bring 1 here, then you multiply with the value on the same line times the 2.455 exponent negative 3, then divided by the first value we began with, which is also 1. In other words, you could not even do this step. You could have avoided it by merely saying if 1 mole of HCl requires 1 mole of sodium hydroxide, therefore, if these are the moles of HCl, similarly they are the moles of sodium hydroxide. Because when you multiply and divide with everything here, you come up with the same answer for the same value. So therefore, we have 2.455 exponent negative 3 moles of sodium hydroxide there. And that is what we have as moles of sodium hydroxide. In our next task that we have, we are now going to find out the concentration of sodium hydroxide. We are drawing closer to find out the concentration of the unknown. This one here, we don't know it. But remember, we knew the concentration of hydrochloric acid. So having gotten the number of moles of sodium hydroxide, remember, sodium hydroxide, we pipetted 25 of the unknown and transferred it in the conical flask. So therefore, that means it is the 25 which completely reacted with the other volume, the average of hydrochloric acid. And that also simply means that if these moles were the ones that reacted completely with the hydrochloric acid. They are the ones found in 25, because it is the one we pipeted into the conical flask. So finding molarity, we'll be finding the number of moles now in 1,000. We are taking to 1,000. From the 25 that we pipeted, we are going to take them to 1,000, and that will be molarity. Because molarity simply means the number of moles in 1,000 cubic centimeters of solution, or 1 liter of solution. So what are we going to do here? We shall begin by having the volume of sodium hydroxide that we pipeted, which reacted, which is 25.0 cubic centimeter, containing this number of moles, 2.455 exponent negative 3 moles of what? Of sodium hydroxide. Okay, these are in 25. So now we are going to shift them and take them to 1,000, which is molarity. We shall have, what about 1,000 cubic centimeter of solution? Will contain what? Or will contain which number of moles? Will contain, we do the same procedure or the pattern that we have been using from above. Record this value first, which is 2.455 exponent negative 3. Okay? Then we multiply with the same value on the same line, which is times 1,000. Okay? And then we divide with the first value up here, divided by 25.0. This is all moles of sodium hydroxide. Not actually moles. This is now molarity. And the molarity, we give it capital M to represent molarity. Or sometimes we can call it moles per liter. That is concentration. Similarly, concentration can be in grams per liter. This is mass. The mass of a substance in 1 liter or 1,000 cubic centimeters of solution. But now we are finding molarity, which is number of moles in 1,000 or in 1 liter. So that's why I put capital M, which is the symbol for molarity. So what we are going to do is to compute. When you compute, what do you get there? When you compute, for me, I get 0.09 moles, which is almost approximately equal to 0.1 when you round it off and molar. And therefore, this is the concentration of sodium hydroxide, which we have been looking for. In our next slide, we find out the concentration now in grams per liter. Remember, I've told you concentration can be in moles per liter or grams per liter. Now, what we shall do is to first get RFM. As we know from our theory, we get RFM by adding the atomic masses of different elements within a compound. And when you look at sodium hydroxide, it is NaOH. NaOH. So what we shall do here to get RFM is to get the atomic mass of sodium, which is 23, plus the atomic mass of oxygen, which is 16, plus that one of hydrogen, which is 1. And we end up with 40. So this is the mass of 1 mole of sodium. Mass of 1 mole of sodium. So what we shall now come and say, we shall say 1 mole, okay, of sodium. 1 mole of sodium the sodium hydroxide, okay, weighs 40 grams, according to what we have done here, because we have calculated the atomic masses of each atom within the compound. What about now these moles that we got? Because I told you now these moles are in 1,000, and so we are getting mass in 1,000. So if you treat moles in 1,000, therefore we can get the mass in 1,000. What about the 0.1 moles of the same sodium hydroxide? We weigh, we get the 40, as I told you, times the 0.1 divided by the 1 which we had down here, and you smartly come up with 4.0 grams per liter. This is now our concentration in grams per liter. That was our lesson, and I thank you so much for attending. Continue watching these videos, subscribe, and share with friends. Also welcome them on this platform so that we can learn from each other. I want to wish you a nice time during the holidays. God bless you.